Greetings. We're going to do lesson 3.3, optimization with linear programming. Grab some graph paper if you don't have graph paper yet. Hit pause and get some. Here we go. When we're doing linear programming, we are graphing a system of linear inequalities. The linear inequalities are called the constraints, and the shaded region is called the feasible region, and that's the overlapping feasible or shaded region. And the vertices are going to be very important for when we do our optimization and find our maximums and minimums. The feasible region is enclosed, or it's bounded by its constraints. Then the maximum or minimum will occur at one of the vertices. Feasible region over here goes down forever. Therefore, it has either a maximum or a minimum. It does not have both. This one would have a maximum, but would not have a minimum because it goes down forever. When it's not enclosed, it's considered unbounded. Here we go. We're going to graph the following system of inequalities. We're going to name the coordinates of the vertices of the feasible region, and then we're going to use those coordinates in order to find the maximum and minimum values based on this information here. First thing we're going to do is change this around to y is greater than or equal to negative x plus 2. And then I'm going to graph, and I'm going to start with x is less than or equal to 5. 1, 2, 3, 4, 5. I think it's right about there. Whoops, did I miss it a little bit? Let me try that again and see if I can do any better. 1, 2, 3, 4, 5. Aha! Very nice. Very, very nice. Y is less than or equal to positive 4. 1, 2, 3, 4. Horizontal line. Let's go with it. Close enough. And then y is less than or equal to negative x plus 2. Grab a couple of points. I got plus 2. And I got negative x, down 1, right 1, down 1, right 1, down 1, right 1, oh, down 1, right 1, up 1, left 1, up 1, left 1, up 1, left 1. And now I can graph the line. Start there. We're going to go this direction. Shaded region, feasible region is in here. Most importantly, we would consider this bounded. Makes a nice little triangle. And we need to figure out what are these vertices. I have a vertice at negative 2, 4. I believe this is negative 2, 4. This one must be 5, 4. This one must be 5, negative 3. So now we're going to calculate f of negative 2, 4. I'm going to plug in negative 2, and I'm going to plug in 4. And we're going to do the math. Negative 6 minus 8, negative 14. Then we're going to do f of, and I'm going to put in 5, 4, 3 times 5 minus 2 times 4 equals 15 minus 8, 15 minus 8, 7. And then we're going to do f of 5, 3. 3 times 5 minus 2 times 3. Negative 3. Excuse me. Almost made my first mistake of the year. This should have been negative 3, which I'm sure you all were aware of. And if we're subtracting a negative, we're really adding 15 plus 6, 21. Oh, I was doing those in red, wasn't I? So that we can find out what we got going on here. What did I have? 21. So I have a maximum of 21 at 5, negative 3. I have a minimum of negative 14 at negative 2, 4. So they provided us with this equation. When we do word problems, we have to come up with it on our own. Next one, graph the system of inequalities. Name the coordinates of the vertices of the feasible region. So the first thing that we need to do is we need to solve these for y. And if I solve this top one for y, I'm going to have 2y is less than or equal to x plus 2, or y is less than or equal to 1 half x plus 1. Second one, negative 2y is, I should use a different color. Second one, negative 2y is less than or equal to negative x plus 4. If I divide by a negative, and divide by a negative, we must switch the sign. So y is greater than or equal to 1 half x minus 2. Watch out for those negatives. And the last one, toughie, y is greater than or equal to negative x minus 2. So I graph the first one, and I get some points, and I go up to 1, and I apply my slope of up 1, right 2, up 1, right 2, and we keep a-going down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, and then we connect our dots, and we can say, connect the dots, la la la, beautiful. Next one, plot those points, I have negative 2, 1, 2, slope of a half, up 1, right 2, up 1, right 2. Oh my gosh, what kind of lines did we just make? Isn't this just something else? I got parallel lines. These lines don't even intersect. No solution. They got the same slope, just different y-intercepts. Check it out. Check it out now. And then the last one should have a different slope, hopefully. The last one, negative x minus 2. And I'm going through here again. Well, let's get a different color. Black. Going through here. And I have a negative slope, so I could go up 1, left 1, up 1, left 1, up 1, left 1, down 1, right 1, and we could see our line. And now when I graph this guy, it's going to look like that. So now the shading, which I kind of ignored right away, the first line, less than, so I'm down here. The second line, greater than, so I'm in between here now. And the third line, greater than, and I go up there, so if I'm here, I'm up here. So I'm going to be in between all of this stuff right here. This is going to be unbounded. It's going to go forever. So we're going to need to pay attention to our max and mins. Let's assume that I colored inside the lines. So I need to get my corner points, which looks like this one is negative 2, 0, and this one down here is 0, 2, 0, negative 2, excuse me, obviously, 0, negative 2. And when I plug these guys in, first I put in my negative 2, 0, and I get 2 times negative 2 plus 3 times 0. I get negative 4. And then I put the other one in, 0, negative 2, and I get 2 times 0 plus 3 times negative 2. I get negative 6. So clearly I have a minimum value of negative 6 at 0, negative 2. But this is where you got to be careful, because this continues up and up and up and up, so there is no maximum value. So don't just automatically assume that the biggest value is the max and the smallest is the min. Since this keeps going up, there is no max. And if I picked another value, pick 0, 0, put 0, 0 in there. 2 times 0, it's 0. And that's bigger than both of those. And then I could pick, 7 and 4, and I could put those in there. And it's just going to keep getting bigger and bigger and bigger. So unbounded just had a minimum in that case. Okay, lastly, we are going to do a word problem, and we need to define our variables, write the system of inequalities, graph the system of inequalities, find the coordinates of the vertices of the feasible region, write a linear function to be maximized or minimized, substitute the coordinates. So you're doing the same thing. The only thing that has been added here is you need to come up with writing the linear function to be maximized or minimized. So if we take a look at a problem like this, which I realize is not very big right now, so let's see if we can make it a little bigger. And we'll read it, and then we'll shrink it up and graph it. A landscaping company has crews who mow lawns and prune shrubbery. The company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. Each crew is scheduled to work no more than 2 pruning jobs per day. Each crew's schedule is set up for a maximum of 9 hours per day. On average, they charge mowing a lawn is $40 and pruning the shrubs is $120. Find a combination of mowing lawns and pruning shrubs that will maximize the income the company receives per day from its crews. Lots of information there. First off, we need to define variables, and I guess it's probably going to have to do with number of mowing jobs and number of pruning jobs. So some people like to use X and Y, or you can go ahead and use M and P. You just have to kind of define which one's taking the X and which one's taking the Y. So M, let's go number of mowing. And then P, number of pruning jobs. What you got to remember about these word problems is you're usually just working with quadrant 1. And so I needed to know that M has to be greater than or equal to 0 and P has to be greater than or equal to 0. You can't work a negative number of jobs. You can be a negative type of worker, but you can't work a negative number of jobs. So we've got maximum of 9 hours per day, 1 hour for mowing jobs, 3 hours for pruning jobs. Some of you are probably 3 steps ahead. 1 hour times every mowing job plus 3 hours times every pruning job has to be less than or equal to 9 hours. There's only so many hours in a day. And then it says that our mowing jobs has to be no more than, well, excuse me. Pruning jobs has to be less than or equal to 2. You can't do more than 2 pruning jobs per day, it says up here. And then our function we're going to try to maximize. We're going to try to maximize our amount of money. So our income of mowing, pruning will be equal to $40 times every mowing job plus $120 times every pruning job. So I have my system of equations, and then we have mowing and pruning. I need a quadrant, and I'm gonna do this guy right here. I don't know, that's probably more than enough. And those 2 axes are M and P greater than or equal to 0. It appears as though I have selected the M as the X coordinate and the P as the Y coordinate when I wrote it down here. I do need to solve that one then for P, because that's my Y coordinate. So I would have 3P less than or equal to negative M plus 9er. P less than or equal to negative 1/3 M plus 3. So I need P is less than or equal to 2. So I am going to have a horizontal line where P is always 2. Less than it would go there and down. That's my P is less than or equal to 2. Next we are going to do up 3. There's a point. And then I have a slope of negative 1/3. Negative 1/3. Down 1, right 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Down 1, right 1, 2, 3. And now I'm ready to graph that guy. And let's graph it with a purple. And I'm there. So if we think about where we were for less than the 2 and less than the line for this guy up here, and I shade that in. Trust me that it's shaded in. And now let's find our corner points. I've got 0, 0. I've got, that must be 9, 0. I've got 1, 2, 3, 2. And I've got 0, 2. And I want to maximize my income. So if I work no jobs, $40 times no jobs plus $120 times no jobs equals no money. So that's how you go bankrupt. You start a business and you don't do anything. Next one, 0, 2, $40 times no jobs, but I'm going to do 2 pruning jobs a day, and each crew could make $240. 3, 2, I'm going to do $40 3 times and $120 2 times, and that's going to be $360. And then I'm going to do 9 mowing jobs and no pruning jobs, and that's also going to be $360. In this case, we want to maximize the income, so we can maximize it with 3 mow and 2 prune, or we can maximize it with 9 mow and no prune, but now we have limited ourselves to being one-dimensional. So even though both of these achieve a maximum of 360, it would probably be best to have more than one thing going for us, which will attract more business, but more on that in some sort of business course. If my picture is terrible, this is what it would look like if you drew it up all pretty. My constraints are the lines, and you can see my corner points, and that is pretty much it. Your homework, I think, only has about 9 problems or so, and a couple of word problems. Please do not be scared of the word problems. I know you all know how to read, and you all know how to graph inequalities, and you're just doing that on the same thing. So have a wonderful time. I'd like to remind you that if you felt that this video was just exhilarating and you want to watch it again, it's on your Schoology in the chapter folder, and open it up and you get a wonderful YouTube video, and it's a good time. So have a great day.